Okay, so discrete random variable. So when you're doing a discrete random variable, what are you going to do is you have to make a table. This is one way of representing. This is called probability distribution table. So here you've been given some value, some variable will be given x. So in this case, your x is let m represent here the number of magazines purchased. That means number of magazines can be 0, 1, 2, 3, 4 or greater than or equal to 5 as per the sum. You have to see that according to the question. And what you do is you write a corresponding probabilities below that. Now that's given in the sum, and sometimes you do work it out. So this is called a probability distribution table. Now probability distribution function has certain characteristics and certain rules. First rule is that the sum of all the probabilities should be equal to 1. Correct. Because it includes all possible outcomes. So your sigma p should be 1. Second property it should have is each of this probability should lie between 0 and 1. Because probability always lies between 0 and 1. You can't have a negative probability, you can't have more than 1. So that's other properties. Now what is the use of this table? The use of this table is to find the mean. In this case it's called the expected value. Expected value is long-term average. Okay. And to find an expected value, we do x into p, x plus x into p, plus x into p, plus x into p, like that. So 0 into 0 0.2, and you work it out, you simplify this, that will give you the expected value. Remember, expected value is a long-term average. It's what will happen over long term. Yeah. Sometimes, instead of giving you the table, they might give you this in form of a function. So what I've highlighted in yellow is showing that in form of a function. Okay. So probability distribution function. So here the question is saying, suppose a random variable x can take value x is equal to 1, 2, 3, 4. They've given the values of x. And the probability x is equal to x, it's like a function. Okay. It's defined. Can be given as kx square, find the value of k. Okay. So you make a table. Correct? You make a table. You take your x as 1, 2, 3, 4, which is given to you. Put each of these values in the function and get the probabilities. Now you should know the property that sigma p is equal to 1. The sum of the probability is 1. You add all this is equal to 1 and you'll get the value of k. Okay. Putting this value of k back in this will give you the proper table now. Okay. And you can find expected. Now you can find expected this into this plus this into this plus this into this plus this into this. You add that will give you the expected value. Okay. So this is long-term average. So if you carry out this experiment several times, per trial, this is the outcome. Understood. Long-term average. Okay, so now in this case, what is happening is you have to find the variance also. Okay. So they have given a probability distribution table, correct? Yep. Find the value of k. So you know that sigma p is equal to 1 as we did in the last sum, correct? So you'll get the value of k. Expectation is 6. Find n. So this into this plus this into this plus 6 into k, now we know is 0.2, correct? N into 0.5. Now why this is getting stuck? This should disappear, yeah. And you'll get the value of n. Okay. Variance. Now this is the formula for variance. It's there in your formula booklet as well. Okay. Variance of x is expectation of x square minus expectation of x the whole square. Is there in your formula booklet? It's there on you have the new formula booklet. Yeah. Statistics and probability. This formula is on page 10. So expectation of x square. Now what is the meaning of expectation of x square? Means you have to square the x and find the probability and find the expectation. Okay. So that means you'll do 1 square into 0.1. 9 times. 3 times, yeah, 3 square, that's 9 times this. 36 times the value of k that we got. Correct? This square, so basically p always remains the same. Correct. Only your x gets squared. Minus, that is the first part. Minus the total expectation. Minus the mean square. Okay. Now whatever mean you had a mean as 6, minus 6 square. And that's your variance. That's how you find the expectation and variance for any standard random variable. And obviously this is statistics, this part. This you have to use in your calculator. This you put in list 1. This you put in list 2. Correct?
Yeah.
Use one variable statistics.
Okay.
Your x bar is a mean and this is your standard deviation.
Got it.
From your calculator. And your variance is standard deviation square. So this will always come with GDC. So now this has been done so that you see the parallels between these two things. It's the same thing basically. That's the whole idea. Now these also have a formula for relationship for the linear function. Now this is also there in your formula booklet. So you need to remember this. Expectation of ax plus b is here this one is a times expectation of x plus b.
Okay.
It's a formula basically. Correct?
Yeah.
And variance is so expectation of x plus b, a expectation of x plus b.
What is A and B?
A and b are numbers. They are variables. Like expectation of 3x plus 2 is 3 times expectation of x plus 2.
Okay.
Variance of ax plus b is a square variance of x.
Okay.
Correct? The formulas do not apply non-linear functions of x values. Means it has to be ax plus b. Fine. Linear.
No squares allowed.
No squares allowed. No cubes. Nothing else.
Okay.
These are not given in the formula booklet.
So what was the difference in variance and standard deviation?
Yeah, that's a good question. Variance is standard deviation square.
Variance. Okay. But what does it mean like in actuality?
In actuality, what happens is when you're finding the variance, you're squaring the numbers.
Okay.
So if your numbers was given in centimeters, let's say, so your variance will have unit centimeter square.
But how does that help us?
That is incompatible with your length in centimeters. To make it compatible with your unit in centimeters, you take the square root again. It's like your error calculation that you do in your sciences. So yeah, so therefore you have to find the square root so that your units become consistent. Basically, therefore you need to work. So practically you work with standard deviation.
Okay.
Because the units are consistent with that of the physical quantity that you are working with.
Okay. Variance will always be the square root.
Variance is the square of that. That's used for calculation.
Okay.
Same thing. This is variance. You apply the formula straight. In this case, what will you do? You work it out basically. If it's not linear, now this is linear, so you can work out the linear function. See. So find the expectation of z and variance of z. So expectation of z will be 1.5 times because 3 upon 2 is 1.5. Correct?
Yeah.
1.5 times y minus half.
Correct.
And you know the expectation of y. And you get this. Variance of z is 1.5 times square variance of y.
Okay. Yeah, a squared then.
Define a new variable q so that q is equal to y square. Now can you use these formulas for q is equal to y square? No.
Wow.
Not linear, no. This is quadratic.
Oh, so you can't use it in this.
You can't use this way then.
Got it.
Then you have to do the long way.
Which
is now if it's y square means you'll keep the probability the same, but your q will be square of each of the y. So this was y, na?
Oh, so just because minus 2 squared minus 1 squared.
Your probability remains the same.
Okay, so 4 1 0 1 4.
And then you find expectation of. So you won't be able to apply this algebra directly.
Okay. Expectation is 5. Okay.
And now we have used this formula already, so that's what it is. This is then your formula booklet. But for this.
Do we have to know? Do they ever ask to calculate magnitude?
No. The curriculum says this is important. This is just a definitional formula.
Okay.
And this is also, not important. Basically, you'll be using this practically. The first one that I highlighted.
Do they ever ask us to calculate any of this by hand?
No. This one they did. No, this one. The kind we did, no, just now.
The last two, no, but so standard deviation never.
No, calculator. They're mentioned in the curriculum. It's a calculator. So now there's one kind of discrete random variable that you have is binomial. Okay. It's a special kind.
Okay.
Like how you have function. Function is a general topic. And within the function you have linear function, quadratic function, log function, exponential function, like that. So in discrete, you have discrete data, discrete random variable. Discrete random variable, under that you have binomial distribution, Poisson distribution, geometric distribution, hypergeometric distribution, which you don't have. You have only binomial. So one kind of discrete distribution you have, that's binomial. Now what is the meaning of bi?
Either
Two
options, or either
two options. So basically any event in this world can be taken as binomial. Success, failure, that's it. So can you say throwing a dice is a binomial event?
No.
Yes. Get a 6 or don't get a 6.
Oh, like that, okay.
So you can make anything binomial basically. So if you consider any of the event as two outcomes, it becomes binomial. The whole idea is that. Binomial is one more thing. So binomial means two, success, failure. Correct? So you have to think of success and failure, and that becomes a binomial. Number of trials. So there will be number of trials given, and they should be independent of each other. Means you are rolling a dice 5 times. So number of trials are 5. And they are independent of each other. Means the outcome of the third trial is not affected by the first trial. Like removing, colored balls from a hat and not replacing them, you can't use binomial. Because if you don't replace them, the probability will keep on changing for every subsequent trial.
It has to be half. Probability always has to be half.
Probability should be constant. Then you can use binomial. Now you don't have to learn the use of this formula. Correct. So you have to use your calculator. Now within calculator you need to now this is a thing you need to remember. You read this as x follows a binomial distribution with number of trials is 4. N is the number of trials. P is the probability of success in each trial.
In each trial, okay.
In each trial.
Okay.
So now your x, they've given you 0, 1, 2, 3, 4. Okay. What is the question? Construct a table for 4, because the number of trials are 4 over here. The maximum number of trials are 4. In 4 trials, how many successes you can have? You can have no success. You can have 1 success, 2 success, 3 success, or 4 success. And you find a corresponding probability. So you'll use binom PDF using your calculator.
Okay.
You have to remember N, P, and X. What is N? Number of trials. P is the probability of success in each trial. And X is the number of trials, number of successes you want.
Okay.
And obviously number of successes will be less than the number of trials.
Yeah.
Less than or equal to, sorry. Okay. Then you use BPD in your calculator.
Okay.
And you fill up the form and you'll get these values.
Wait.
Now basically you need to remember one thing. Now this is just a derivation we try to do. But you can simply remember for binomial, expectation is NP and variance is NP 1 minus P.
Is this what you mean?
I doubt this is given. Just check. Binomial, it will go further down. No, it's not given. So you have to learn this. It was given earlier in the old formula booklet, but now they removed it.
Expectation is NP, variance NP 1 minus P.
Yeah. So for binomial, you need to remember this. See the formula booklet, it was there earlier, and the new one is not there. So you have to just apply the formula. Poisson you don't have. Now, what is you need to remember in your calculators? There are 2 things you need to remember.
Yeah, what are you?
Probability when you're doing so if your x follows a binomial distribution n comma p, when your probability x is equal to x, we have to use BPD.
Okay.
And when your probability x is less than
or equal to, use BC.
X or so BCD, or when your probability x is greater than equal to x, use BCD because you have a lowered upper.
Okay. When you are lower upper, you use BCD. When it's fixed, you use BPD.
Yeah, BC. So binomial cumulative distribution is you're getting 0 plus 1 plus 2. Like suppose if you do BCD of 2, means either you get 0 successes, 1 success, or 2 successes. Or you can do BPD 3 times and add those values. If you don't like using BCD.
Yeah.
So that dealt with discrete. So under discrete we had only one type binomial. Now continuous probability distribution. Now in continuous probability distribution,
this is different from discrete.
This is different from discrete.
Okay.
Discrete is countable, continuous is measurable.
Okay.
Correct? So this is something you can measure. Now, in discrete and probability distribution, we know that sigma p is equal to 1. You're the integral of the function, and that function is called the probability density function. Now, probability density function is a function which satisfies the property that the integration over the entire domain is equal to 1. The usefulness of this probability density function is to find the probability between two values.
Okay.
So if you want to find a probability between two values, between A and B, obviously it should be in the domain.
Yeah.
Then you integrate it, you do a definite integral between those two variables of the function, and this area will give you the probability that that event happens between A and B.
Good.
That's the whole idea basically. Correct? For continuous probability distribution function, we have the following definitions. Mode is where the maximum is.
Okay.
So mode will be where the maximum of the function is. So where the maximum of this is your mode. Correct? Or you look at the global. Sometimes you know the endpoints may be maximum. Like suppose if the function is like this, then the endpoint may be maximum.
Okay.
So you see what is maximum. That corresponding x value will give you the mode.
Okay.
Median.
Maximum measuring of your graph.
Of the graph. Okay. Of the function. You just sketch it. And you
within
see
your domain or anywhere?
Within your domain. Because
okay. Not
this is very domain restricted type of function.
Okay.
I mean in this case. Your median is a value below which 50% of the data lies.
Okay.
So you integrate from the lower limit minus infinity to the median of the function and you call it equal to 0.5 and you solve for m. That m will be a median.
You can do the same thing in reverse also, no?
You can also do in reverse. From m to infinity if you take, it can be 0.5. It's fine, no problem. This minus infinity when I write refers to the lower limit of the function which is given. If you want to find a lower quartile, then you go from minus infinity to that lower quartile. Okay. And that area should be 0.25.
For lower quartile, okay.
Upper quartile?
0.75.
0.75. If you want to find the interquartile range, now this is interesting. You take the integral between Q3 and Q1.
We don't know what they are.
We don't know what they are, but we want Q3 minus Q1. So when you integrate it, you will get the upper function minus the lower function. You will get the upper value minus the lower value.
Okay.
So you'll get Q3 minus Q1 directly without getting Q3 and Q1 individually. So you integrate and substitute. This can come in your paper 1. Okay, find the interquartile range of a probability density function has been given. Find it out.
Okay.
So this is tricky, yeah? Now, mean expectation x fx. Huh? Okay. Now integral of fx is 1, not x fx. This is integral of only fx.
This is 1.
This is expectation when you x fx.
So fx means only a probability.
Yeah, fx is your probability density function.
Like
you multiply that by x.
So that's
and then you integrate it.
Okay.
Okay. Variance is expectation of x square minus expectation of x the whole square as we did. But in this condition, what is your expectation of x square? X square into fx. So you take your fx, multiplied by x square, integrate it over the entire domain. That will give you the first part. You take your fx, multiply that by x square, integrate it. That will give you ex square. Minus mean so you take your fx, multiply by x, integrated, square. Like see, this is the typical sum that he'll ask you. This has everything in this. So the function fx is kx over this domain and 0 otherwise. That means if I draw a graph over here. So from 0 to 2, it's some slope kx. We don't know what k is. So they're asking you first, find the value of k. So we use the property. What's the property? That integral of fx is equal to 1. So from 0 to 2, fx dx is equal to 1. Correct? So you key x is 1. So integral of k is constant. So integral of x is x square over 2. Substitute and solve for k.
Okay.
So that means my function is half x.
Yeah.
Where will the mode be?
Halfway through.
Mode is the maximum.
Oh, sorry, mode is maximum.
So that means it's a linear function. The maximum will be at the end point.
Yeah.
So mode is 2.
Correct? Mode is 1.
No, that's a mistake I made.
That's actually 2.
So this is 1. This is your mode. So mode is 2. That's a mistake I made over here. So mode is 2. Mode is the x value. From the x axis you can do that.
Not the y.
Not the y. That's a mistake I made. Median.
The halfway.
You integrate a function from 0 to m, where m is to be found. Achha, this is your minus infinity. Means your lower limit in this case was 0. Because your function exists from 0. It did below that, and you integrate it. Okay? And you solve for m.
Okay.
Mean, how do you find mean?
So xfx.
Xfx. So you take your fx, multiply by x, you combine this, and then integrate it.
Got it.
What's your variance? X square fx. So you find your x square fx. So you take your fx, multiply by x square. Correct? So it becomes x cube. Okay. Integrated. That will give you this first part. And then minus your mean square. Minus mean square.
Okay. Got it. Standard deviation is
square root of variance. Calculating probabilities. So for a continuous random variable x, we generally do not expression of the form px is equal to x. We integration is over a region. It cannot be for a particular point. So you always have to find a probability that it lies between two values. Okay, like this one. A continuous random variable x has probability density function. This has been given to you.
Okay, so
find k. So your integral of this function over the domain is equal to 1.
Yeah.
You solve it basically.
Okay.
Correct? What is the probability that x is less than 0.5? So you find the area.
Okay.
Your x is 2 now, so 3x square. You integrate the function
from 0 to 0.
From 0 to 0.5.
Okay.
Basically. So that's your probability. If they say what is the probability that it lies between, let's say, suppose if they ask you what is the probability that it lies between 0.5 and 0.7.
I put my lower limit as 0.5, upper 0.7 and do 3x squared.
Correct. And you get the answer.
Got it.
That's the use.
Understood.
That's the use of probability density function. Find the value of x such that probability x is less than x is 0.5.
Upper is 0.5, lower is 0, and 3x.
0 to x, because you want less than x now.
Oh, less than
0 means because this is 0.
Oh, so my area is 0.5.
The area is 0.5. Basically, you're solving for x.
Got it.
This you go through. I'm not wasting time. It's an important sum though. But you will be able to do it now with this concept. Now, in continuous random variable, you have only one term, normal distribution.
One second. Normal distribution is part of
continuous. Yeah. So binomial is part of discrete. So first you learn discrete, binomial distribution.
Okay.
Then you did continuous.
Normal. Normal is at 65, 95, 97 rule.
Yes, that rule which is there.
That's 65, no?
Yeah. 68.
68.
So in normal distribution, it's a specific type of distribution which is characterized by this function. You don't have to learn this function.
Okay.
It's characterized by this function which is there, which you don't have to learn. It doesn't matter.
Okay.
Because the function is not important. The probability is important, which is got by integration.
Okay.
And that way you don't have to integrate, your calculator does that.
Okay.
And in the calculator also, you have to use NCD only.
Where does this come from?
Distribution, normal, NCD.
Oh, this is that
Correct. Lower limit, upper limit, mean and variance, standard deviation. So this is a bell-shaped curve, in which 68% of the area, 68% of the area lies between what?
For one standard deviation.
One standard deviation. 95% lies between two standard deviations. And 99.7 lies between three standard deviations.
Correct.
You don't have to learn this because your calculator will be using this all the time. So basically what you have to use when, acha, now how do you see this? Your x follows a normal distribution.
Okay.
With mu as mean.
Okay.
And this is variance.
Not standard deviation.
In your calculator you'll be entering standard deviation. Okay. But they'll give you variance over here. So don't mess this up.
And this again.
Yeah, calculator distribution LCD. There you're entering standard deviation. So and also it flipped. Here the mean is coming first, and then the variance. Then the standard deviation is in there. So while entering the data, just be mindful. I don't know why Casio has done that. They could have left it this way only, while filling up the form. The backend they can do that. So you can write to them. So again, normal distribution. What is happening is, where if you have an interval, correct, you have to use NCD. You have to use NCD, normal cumulative distribution, between region A and B. Okay. So between A and B. Now whether it's less than or less than equal to, it won't matter for continuous. Okay. For discrete it will.
Yeah, because then the next point is
yeah. Here this is x is greater than, so you put your lower limit as A.
This is inverse.
Upper limit is 10 is to 10. No, this is still NCD. Okay. Inverse is when you know the probability and you're finding the value, x value. Oh, okay. Here you're finding the probability. Okay. Your NCD is used to find the probability. Got it. Inverse is used when you know the probability and you're finding it. Okay. Yeah, this is again, you do your lower limit will be minus 10 is to minus 10 is to 10. Then they are very there. You can also put minus 10,000 if you don't want to. It won't matter till that value.
So wait, so for binomial, my expected value is just NP and our variance is NP1 minus P.
Correct.
Okay. That's for binomial.
That's what we. This is important.
So this will become 1850 to 2050.
Correct. Yeah, your model is, that this will, you have to get it in between that. Here. So when you x minus a modulus is less than b, then you have to solve this equation. Okay. Just remember that, then use it, then become the lower limit, upper limit. Sometimes you know the probability and you want to find out the value that goes with it. So you know the probability and you have to find this. That's your inverse normal. Okay. Like here they have given, if 90% of the bulbs have a lifespan of x hours or more, so x hours or more, so you have to decide, find the value of x. Okay. So you'll use inverse normal and you have to just fill up the form. So your this will become the probability. If modulus of x minus 2000 close modulus is less than a is 0.9, find the value of a. So that means it's centered at 2000. It's going a down and a up. This is less than equal to a. Okay. Correct? And this area is 0.9.
So I put center.
Correct. So you go distribution, normal, LCD, center.
Area 0.9. My mu is.
I think so. This sum has been given to you. In the light bulb problem above. Yeah, here.
Standard deviation is 120.
Correct.
Mu is 2000.
2000.
1802 to 197.
Yeah.
Got it.
Important. Now, standard normal distribution is a special normal distribution which is denoted by Z. Its mean is 0 and variance is 1. So all your normal distributions which are there, can be reduced to a standard normal distribution.
Okay.
It's like scaling it down.
Okay.
You scale it down in such a way that the mean becomes 0.
Variance becomes
1. Variance becomes 1.
Okay.
So, and to get it back, this is the formula to scale it down. Z is equal to x minus mu upon sigma.
Okay.
You do that for each data point.
Okay.
And then you scale it down.
Got it.
And this is called the Z score. Now, so Z score. So how do you can you find NCD on your calculator?
Yeah.
But you have to use your mean as 0 and variance as 1. Standard deviation is 1. Yeah. So NCD, yeah.
Mean is 0. Standard deviation
1. And if you use any values, you will get your NCD.
But what about lower and upper?
Lower and upper, they'll be given. That will be your Z score. Lower and upper should be your Z score.
So let's say 1 and 10.
No, 10 will be too big. In your Z score, when you do the Z score, all your data gets over within 3 standard deviations. So see, this is 0, this is 1, this is 2, this is 3. And this is your Z score. Minus 1, minus 2, minus 3.
Okay.
So when my Z score is 2.5, what does it mean?
Within 2.5 standard deviation.
Above the mean. That's 2.5 standard deviation above the mean.
Got it.
When my Z score is minus 1.5, what does it mean?
1.5 below.
So that means that particular this value is your, this is 2.5 above. This your X is here.
We're just scaling it down.
You're scaling it down. Yeah.
IQR won't change.
Yeah, nothing will change. You're just scaling it down. Like see here. This is very, very important. Z score can be used to find the mean and variance of a normal distribution. Very important. So if you don't know the mean or variance, then you have to use the Z scores to find it. How will you do that? Let's have a look at this now. Given that X follows a normal distribution, the variance is unknown, and they've given you probability X is less than 106 is 0.8849. You have to find the standard deviation. So always start with drawing a diagram. Draw a bell-shaped curve. Probability that X is less than 0.106 is 0.884. Now one thing is very sure, you have to use inverse normal.
Yeah.
Because you have this, the probability. Now the moment you open, try putting in the inverse normal. Inverse normal. Left. Probability left, yeah. This left you take. Now do you know the mean and the corresponding standard deviation?
No. I know the mean is 106.
You know the mean, but you don't know the corresponding. You need to know this as a pair. If you're entering this, you have to enter this. You can't enter anything else. So then you take the scaled values.
You put 0 and 1.
You put 0 and 1. But the moment you put 0 and 1, the output won't be X. The output will be a Z.
And your Z comes to 1.1.
That's your Z. So if you put 0 and 1, you won't get X. You'll get Z.
Right. And then you put
now you use Z value in this. So this is Z. Okay, and this Z corresponds to this mu. And this X.
Correct.
So the 106 when you scale down will become 1.119.
Yeah.
And mean we know 100. You have to find the variance and use this to find the standard deviation.
So formula for Z is X minus mu over
sigma.
Sigma.
Yeah.
Not sigma.
So basically Z is used, Z score is used to find mean when standard deviation is given.
Yeah.
Or to find standard deviation.
When mean is given.
Got
it.
So one.
Not variance. Variance.
Yeah. Like see here both are known, but they are giving you two set of values. So you will do this simultaneously and get it. This is the toughest possible sum.
This one?
Yeah. So you can try solving this sum, it's quite easy.